A change in his primary duties to watershed work from ag work. The other thing you should know about Mark is last summer, he spent most of his summer down at Hibernia Dam as our primary inspector on that rehab project. And now he's the project manager on Beaver Creek. So with Mark, with that, Mark, I'm gonna turn it over to you.
All right. Thanks, Heather. I want to at least have my video on to kind of put a face to the name. I've been around for about 11, 12 years now, so you might recognize me on the video if you haven't spoken to me. But one thing I definitely want to highlight is I'm new to this position in the dam world, and some of you might be thinking NRCS and dams. I'll get into that a little bit. But Tim, I think you titled this "Lessons Learned," and every lesson of RCC and this project was learned for me and probably the staff. And we actually had Gannett Fleming, were the designer of this, and they actually assisted us with a training. And I used some of their slides that they shared with us after the training. And so I have a jam-packed presentation. I'm going to try to move quick. We can kind of ask questions and things at the end. Adam Winey is also on the call. He was the primary inspector, quality assurance inspector for NRCS on the site. So if you want to chime in at any point, Heather as well. But I'm going to turn my video off and get started here. So yeah, so lessons learned. I'll pop through. Let's see. Okay. So the dam program. So NRCS in 1954, Flood Control Prevention Act came about, and we were able to fund and install some dams for owners and sponsors. So for flood protection, soil erosion reduction, water supply, recreation, and fish and wildlife. So those are some of the purposes why we did some of these dams. Most of the dams in PA were built between 1960 and 1985. Over 80 dams in Pennsylvania. The last one completed was in 1995, and there are over 11,000 built in 47 states. Just wanted to pop this slide in here for some facts for dams in Pennsylvania that NRCS was involved with, some average heights. I'm going to read all this off, but up to 98 feet high, pool area, let's see, 6 square miles average drainage area, population at risk, average of over 1,000 people. So these are very important dams. The dams were generally built for up to a 50 to 100-year lifespan. So if we're looking at some of those timeframes I just talked about, and I think, Heather, I pulled this from a slide deck from 2016 was the date. So every day these dams are getting older, so some of these percentages might be upped a little bit. But we're looking at some that are over 50 years. So what should we be doing as an agency? And that's where we're getting into rehabbing and assessing some of these dams. Most of the dams in PA are aging gracefully. So why rehab? I have a few listed here. Just deteriorating concrete, some spalling. I know a typical ag projects, if you look at our construction specs, I think lifespans noted as 25 years. But some of these harsh conditions, some of these risers and impact basins, but we've seen very good success, but there are some minor issues at spots. Some sloughing in the spillways or in the embankments. And then the big one here at the bottom, meeting current state and NRCS safety requirements. They've changed. So we need to assess these dams accordingly. Here is a map of PA dams. We have some in the design and planning phase, so there'll likely be a lot of construction coming down the road. So like I said, we had an RCC training from Gannett Fleming that was huge looking at the workload we have down the road. 2 have been rehabbed up in Potter County, North Fork, and then Hibernia, the one I was involved with, was rehabbed, and now this one here is Beaver Creek, right next to the one I worked on last year. So talking a little bit about Beaver Creek, it's in the Brandywine watershed in Chester County. It's construction in 1976. It's owned by Chester County Water Resources. So we partnered with them when it was built, and they still own the dam and were interested in the rehab program. It was built for flood protection. Height of the dam's 35 feet. The length of the embankment's over 1,300. Drainage areas close to 2,000 acres. Floodwater capacity is 184 million gallons. And the water surface area was 11 acres that they're going to operate it now as a dry dam. So I have a little asterisk there. And this PA 433, that's kind of how we code PA, and then the number is how we code these dams across the state. The rehab benefits were included flood protection, some dam safety elements, water quality, public safety with the pool area, being able to make it a dry dam, wetlands, being able to dry it up, create some naturalized wetland and wildlife habitats, and then just maintenance and safety workers. I know getting out to that riser, they had to take a boat out, so having it in a dry dam would make that a little bit easier. The dam, once through the rehab, they assessed it again, and it protects over 4,000 residences, 8 schools, 2,500 employees, and the assessed value of all the saved of the property's assessed value was over 300 million. So it's very important dam out there. The rehab components. The one I'm focusing on here is what we did in the auxiliary spillway. We armored the control section with a roller compacted concrete drop structure. So that's what I'm going to focus on here. Some of the other elements, they lowered the crest elevation to make it hydraulically flow the design storm flows. We made drainage improvements. We put a trench drain in the toe, and then part of O&M and assessing these dams and interior piping is getting cameras installed in these pipes to get them viewed. And a lot of the toe drain, so a 12-inch pipe in the middle of embankment. So the modern cameras can maybe make it through 190, but there were multiple 90s in this 12-inch pipe. So we did a bunch of cleanouts and access ports to be able to get a camera and see and inspect a little bit better. And then the big one that's ongoing right now, which we have another inspector out there for this portion of the project. They are replacing the riser tower. So I'll have a little pictures at the end on that, and touch on some of their construction timing and things like that. So this is what I'm focused on my presentation. A little bit about the job. The contractor was selected was KC Construction, and they had a winning bid of 2.24 million. And I have an asterisk there because there were some contract modifications and some things we found on site. So that is north of that, definitely north of that amount right now. Engineer's estimate was 3.5, 3.6. We had 4 bids. The next lowest was 4.3. So we are extremely happy that we had one within our engineer's estimate and what we had budgeted. But you can also see we were very surprised at how low the low bidder was, and there are some reasons for that. And then the high bidder was 6.3. So I wanted to show some of those figures. Jumping into the design here, this is the cover sheet. You can kind of look at the map here, kind of where the site is in Chester County. I have better pictures of aerials, but you can see it is a golf course. This is an Apple Cross Country Club. So we had some $1 million homes here, so we kind of had to have a buttoned up site. with that. Touch a little bit more on the design. There were 24 construction specs, so it was a thick construction spec binder. There are 46 bid work items, and the RCC spec itself was 30 pages. So just a lot to learn and prepare for, and then not to include all the ASTMs and all the testing procedures to know and understand. So Adam can attest to all the studying. Moving along, here's the existing plan view, the crest of the dam, the riser structure, and here's the auxiliary spillway. A little bit more detail. So here's the auxiliary spillway. Here's where we're going to be doing our work and controlling, and I'll touch into what we're doing and why. But here's the water as it would flow over heavy rain events that would flow through the spillway. So you can see the spillway runs right through. I don't know if this is hole number 1, but yeah, it's and here's homes that had a nice view of the construction. This was taken from the presentation I was telling you earlier from Gannett, showing a spillway flowing, which means there you have significant rainfall for sure. Here's a site in Wisconsin. Here's before, here's after, and showing the spillway getting that much velocity and flow that it actually eroded back to the dam itself. So ultimately running into a breach, which we've seen that in the news. We've seen this happen. That's why we're rehabbing and getting ahead of these types of things. So proposed site plan is to do a drop structure, and they did geotechnical borings to see where bedrock rock was. So what we're going to do here is, well, what we have done is put in a roller compacted drop structure, which has a control section, has a slope down into a sealing basin to dissipate flow. So that's the structure we're looking at. Here's some more detail of the steps. Here we did a perforated pipes behind the structure itself to help relieve pressure and equalize, so that everything can equalize water in under the. Here's a concrete cutoff trench that was down in the control flow as well. Here's a cross section of the area. So here's showing some of the bedrock in this particular cross section area where it was anticipated to be. Here's showing your 1 foot thick layers of RCC, the drainage pipe through, a sand layer, and then a coarse layer on top of that. Here's showing one of their bore logs. They created a little model here showing how this drop structure would sit in and tie into erosive resistant rock. Here's some of their corings that they analyzed in the lab to see what kind of flows they can withstand and what would need to be removed. Here are nice renderings that Gannett Fleming put together, kind of showing the spillway itself as is. Here's what we're going to be doing. We're going to be excavating into the control section here, down to bedrock, competent bedrock, and build this structure back in as we see here. And then we're going to cover this thing back up with topsoil. So it's going to look like it's never there. Currently, it's been seeded. We're done. It's been backfilled, and that's exactly what it looks like now. They took, I think, close to 2 feet off in the control section, like I mentioned, to be able to have capacity through here. Final showing. And then this was a big part, was cleaning the bedrock and getting down and considering what is non-erodible bedrock. It shows a lot of the crevices and having to get this cleaned out, and they called it the chewing gum test. So if you would drop your gum on this, you would pick it up and keep chewing. That's how clean we wanted the structure before RCC was put in. And you can see what they kind of showed. They anticipated different elevations to hitting this bedrock. So that came into big effect, as I can tell you, of a big contract modification. Here's kind of a showing a cross section with the drainage and a little more detail. I wanted to share a few slides just to get into RCC and what it is. I like this slide a lot. What is RCC? Really cool concrete, really cheap concrete, really crappy concrete. That's some things that you may have heard, but it's roller compacted concrete, and it has been a massive development in the dam world. Per ACI 116, RCC is concrete compacted by roller compaction, so it's concrete that is in an unhardened state that will support a roller while being compacted. It has zero slump, no forms, no finishing needed, no steel reinforcement, high production placed with earth volume. I might have to keep moving here. I might slide through these. Here's showing a no slump. Here's showing a conventional concrete slump. Here's a little schematic of where RCC lands. It's not a soil, but you do moisture density testing on it. And it has a little bit of asphalt comparisons. It is rolled in place with a smooth drum roller, but it has concrete properties as well. Here's showing it where it lines up on a water content and cement content. Here's conventional concrete, so it's a lot less water than conventional, obviously, so you can get on it with the equipment. Here's showing conventional concrete next to RCC, a picture. You kind of see the difference. You can attempt to form it as best you can, but it doesn't look quite as nice. That's why sometimes, or pretty often, a lot of these rehabs, we are covering them with topsoil, which the topsoil is sacrificial. It will wash away if flown, if flow does go through the spillway, and that's a known thing, known by the dam owner, that would have to be put back if it does flow. Benefits: it's ecological, it's fast production, early load carrying capacity, low heat production, durable, and low maintenance. This was a chart they showed comparing conventional to RCC. The spec for RCC was 3,000 PSI at 28 days. So that's what we required, what we wanted to see. We were getting cylinder break results at 7 days on the mix they used at over 4,000 pound average. And so in my opinion, it looked like they had a lot of cement in this mix, and it had a lot of early strength to it as far as these results go. The mix is very typical to your typical RC or concrete, your Portland cement, your water mixtures. So it's very similar to concrete, just different proportions. Coarse aggregate was 57 stone. The fine was concrete sand. And they used a pre-mixed cement slag mix that was 75% and 25% slag. And then these are a preliminary mix that we had in our spec of what they typically have in RCC. Mix. So jump into the project. Here's the site. Here's the job trailer. We came off this access right along the golf course here. They had orange construction fence. I know when I was out, I got close to a dozen balls. Adam, I don't know how many you collected. But they couldn't make it past, so if they airmailed the green, there were lots of golf balls available. You can see how close these homes are. Dust was an issue. We did get a complaint. They came out with a water truck and tried to keep dust under control. But here's the control section starting to be dug out. Massive spoil pile, massive amount of earth being dug out there, and you dig it out, you put your structure back in, and all that earth goes right back in to cover it up. So you can see this was the county owner has a drone, and he provided almost weekly pretty awesome drone photos for us. So a lot of these are from them. This is them under construction here. Digging, once they started to expose some of the rock, we had Gannett Fleming, geotechnical engineer, out to give a baseline for the crew members to see how much they need to rip out, what was good. So this was a day we had them out. Here's some of the site. This is a little like weed whacker contraption they had made that had kind of brushes on it that they would run and try to clean the rock with. It was dry here. This is actually a tile drain that we found. It wasn't in the rehab drawings, but it was in the as-built. But lots of seep, lots of water they had to deal with in here to get pumped out. And that was a significant element to the rehab, and a lot of work went into dewatering the site. Here are some sumps they put in, and continuously 24 hours a day for 2 months, they had generators and pumps running out there. Here they're digging, and they were quality control and on getting the survey limits they needed. This is showing some of the water. Here you can kind of see these banks being shaped as they go. Here's showing about down the grade. I wanted to touch a little bit about this detail. I mean, we weren't completely confident. They did a lot of borings, but we weren't confident exactly where they'd hit bedrock based on a lot of these illustrations. And in this right side, we'd never hit bedrock. We dug a lot further, and the contractor's like, how far do you want us to dig? We could just keep digging. We did some analysis to determine how far down we did need to go based on the stream elevation at the outlet. We wanted to be below that. So if this thing did start flowing and eroding back, we would be at a depth that it wouldn't chew out underneath the RCC. So we added about 9 feet of extra excavation. So big modification to that process. Here's showing the detail of that change. We stepped it down a lot further, thickened the sealing basin, and took it to a lower elevation. Hurricane Ida. It seemed like it was a challenge to get this rock cleaned. It seemed like they'd get it cleaned, and every weekend it would rain, and they'd come in Monday, and the laborers were very distraught to see what they had to come back to on a Monday and keep doing what they just did. Ida dropped almost 7 inches in 8 hours. In a 15-minute, it dropped an inch over 15. This is the highest the water ever got at Beaver Creek, and you can see how far close up it got to the work they're doing. Keep moving along here. I'm sure I'm probably pushing it already. Here's the tower. Here's the batch plant. Here's where they mix their RCC. They had 2 volumetric trucks, 2 silos that held about 50 tons each, a 50-foot conveyor that would fill these dump trucks with sand and gravel. They were noting that peak production, they could do about 100 cubic yards per hour. So that's 2 trucks producing 1 cubic yard per minute. So pretty heavy, pretty awesome product, quick production, quick placement. You can imagine doing that much of conventional concrete. Normal production, I think they ended up working more at this rate, if not less, 80 cubic yards per hour, because there were a lot of components. They were backfilling as they went and doing a lot of other elements as they went. Here's a quick schematic of these volumetric trucks they would use. This is partially why they were able to bid so much lower. We specify in the specs a pug mill setup where they'd have their slag or fly ash separate, and they'd mix everything on site. They would have this mixed concrete come in, it would dump in, and then they'd have a truck running for this would be the 57 stone in the stand, and they'd be filling this. They'd have this Volvo dump truck running nonstop, filling each truck up with sand and gravel, and it would conveyor mix with water, and it didn't take much in the trunks where it mixed everything and came out the end, and it was a very well mixed product. I was very impressed. Here's some close-ups of the process. There was a test section. That was a bid item to do a test section, and here's a cool apparatus specific to RCC. This is a VB test. I would consider it similar to a slump test for concrete. Basically, this would shake it, and they'd have this weighted thing on top, and it would shake it, and then you time it until the paste kind of started easing up, and you could see the paste on top of this little ring. And that gave a good test on where the water content should be. And here's Gannett. They helped us with the tech section to make sure we had the properties we needed to move forward. I mentioned that it has soil characteristics. So when you do soil earth fill, you do compaction density testing. So we use the nuke gauge to run it for this RCC. Pete, I think you're on the call. This is people might recognize him. Here's how you do cylinders with RCC. You wouldn't use a rod. You use this called a Hildy hammer with a round plate, and you needed a shell around the plastic cylinder so it wouldn't bust as you compacted it. So you'd still do 3-inch or 3 lifts in this thing. And here he is. Pete broke our brand new Hildy hammer on the second cylinder.
Thanks, Mark. Thanks.
Yeah, Pete, of course. And actually, we had an issue with the first test. It was coming out a lot. The first tech section, we actually did 2 days of testing. It was a lot drier, and I think, Pete, that's kind of why we were really pushing in the same concept. You vibrate until you see the paste kind of coming out around this thing, and the paste wasn't really showing it, so we were really pushing and compacting. So I think it's not all your fault, Pete. Reason for the text section, it's really for the contractor to show means and methods and everyone to get on the same page. How they would face it, how they'll roll it, how many times they need to roll it. I know I'm going quick, but matter of time, I'm just going to keep rolling through here. So there is a parameters to get to for what we needed and what nuke gauge parameters we needed to meet. You had this theoretical air-free density that you need to be 97% of that. So the nuke gauge reading needed to be right around 150 dry density. And here's a wet density moisture curve that they ran. So they were getting around 5% moisture content, and you could see they would be within the needed parameters with that. You can see optimum's up at 8, but the contractor, that's getting pretty wet. They prefer it more on the dry side, more in the 5 to 6, where we could have gotten probably a lot more compaction if they had it a little bit wetter. But we were happy with where they're at with 5 to 6%. Here's kind of right before they started RCC, what the site looked like. You can see this cleaned rock. Some of this was dirty. That was actually above the elevation we needed to go, so they didn't have to clean that off as well. They did get plastic on the side slopes to help with some of the rain events. But you can just see every time it rained, it just sloughed in, and they'd have to be back in there. So these are some of the sump pumps that were in there to do water. That was a challenging and an issue with the golf course because it was pumped and they just had continuous water just kind of flowing through that fairway. But we were telling them it's temporary. It has to happen. And then before RCC was placed, they used backfill concrete to fill in any of the fractures, any of the voids to get a smooth surface to do the RCC. So here's the crew doing that, and he was vibrating that a little bit. Nothing was formed, no rebar, just kind of setting themselves up for RCC. Here's right before they started, cleaning mud off, and then a component for RCCs, you always needed a bonding mortar put down on all the rock surfaces, all the backfill concrete. And that was basically the RCC mix without the coarse aggregates, without the 57 stones. So that was pretty liquidy, and they'd come down and scoop that out and place that ahead of RCC. Here's production with the dump trucks. Here's pushing it. There were 1-foot lifts. They put it in probably 13 to 14 inches before compacted down to the 12 inches. Here's a mirage of different photos showing the process. The sump pumps, actually, the pipes stayed in. So once they got up to a certain elevation, they just grouted them shut. You can see that there. Some of the testing, some QA, measuring the lift thickness. You can see kind of how consistency it looks like. We were pertinent to make sure these tracks were not, so anything that was already rolled and compacted, we didn't want the tracks of the roller to go over them, so that here they are protecting that. We got some cold nights, so they were protecting that with plastic. Here's some photos of the drain pipe going in. Some of the drain pipes early on, they started forming it. I think they stopped doing that, so they did use conventional concrete around the pipes so they had to kind of wait for that to cure till they could get back in and start rolling RCC above it. Here they're videoing the drain pipe to make sure. We wanted that to be done to show that there were no issues or no collapse of pipe after the fact. Here they are doing earth fill as they went here. The picture of the earth fill. Here they are, these lifts coming up. You can start seeing this horseshoe being made. So in hindsight, it would have been nice to see the project done without being earth filled, but it made sense. This enabled them to keep having access to dump more and to keep the project rolling. Here they are. Here he is facing that slope. They run through with the compaction plate on their Kubota. Here they are with some more bonding mortar. And here we are. This is what it looks like now. Backfilled, complete. Let's see. I'm over time, Heather. I'll wrap it up here quick. So it took about a month to do. They were early on. Talks were of this project. It's going to take 2 weeks. No issues. We'll get in and knock this thing out in 2 weeks. The economy really hit hard on this project. They just couldn't get truckers. The product was at the plant. They just couldn't get truckers to deliver it. So they could get so much a week. There's some weeks they got 2 loads, which would fill 1 tower, and they would do bits and pieces at a time. So it got really frustrating. The economy even affected piping. They had to submit different pipe. Nothing was really getting manufacturing. Everything was delayed. Here's a breakdown on quantities. About 4,500 cubic yards of RCC was placed, 300 yards of backfill concrete, coarse fine, about over 22,000 cubic yards of excavation from the spillway, and then the earth fill that went back in. Lesson learned for me, that's the title of the talk. Man, everything in the damn world is new to me, but definitely RCC was eye-opening and a lot to learn, a lot to study. The spec was very specific. The economy was a huge impact, like I said. The watering was intensive. It took a lot of time to do. The rock surface preparation was a huge process and very demoralizing, I'm sure, for the laborers and the crew to have it buttoned up on a Friday, think they're going forward, and they come out and have to do a lot of things again. The big element was bald eagle was in this tree right here, right in the smack dab in the middle, and that limited our construction window from August to December 31st. So really, they have 2 weeks now to get all the big equipment work done. And so that's what I had. Heather or Adam, you can chime in. This is actually pictures of the riser work that's happening as we speak. They had a coffer dam up to divert any higher flows. I'm not sure the coffer dam was really needed. I don't know that we had any storms since it's been in that were too significant, but the water is being diverted. Here's the base of the riser. Here's a foam transition, was pretty unique that they put in. And this is where we're at now. They're actually going to pour the lid tomorrow. But here's this riser structure going along. It's cold weather, but we've had some decent stretches. I feel like they've poured when on good curing windows. So yeah, questions, comments? Adam, Heather, any comments to add?
The only thing I can say, Mark, and I think you gave a really nice presentation, is that if it sparked anyone's interest, we should have another one coming under construction this year and probably the one after that, and one a year at least for the next couple of years. So we're always looking for inspection. We're looking for engineering support on them. It can be a good experience. And these are really good projects. So, Mark, I didn't see anything in the chat box.
Okay.
I think we're going to hold off on anything just in the interest of time until the end. And if anyone is also welcome to reach out to you directly with follow-up questions on the project.
Absolutely. Thanks.
Yep, thank you. I think I saw Mark jump on from Nutrient.
I am on.
Yeah, there you are. Welcome aboard. We are going to transition over to Mark Storman from Nutrient LLC. Mark has worked in the dairy and food processing industry over the past 40 years, holding a variety of project operations and material management positions. Mark came to Nutrient because of his renewable energy industry background and as an outward growth of his experience with developing and building CNG stations, anaerobic digesters, and the biogas upgrading systems for the dairy industry. So Mark, you come to us with a wealth of information and background, and we appreciate your time, and we're looking forward to hearing about Nutrient offerings and carbon fuel standards.
Thank you, Heather. The one thing I probably should mention is I am proud to say that my family and a bunch of our children were born, and we lived in Pennsylvania, just outside of the Chambersburg area for about 5 years, and always enjoyed our time there, and really consider PA one of the most beautiful states we've ever lived in. So happy to be able to join you. I'm not sure exactly how you've been structuring this discussion. I'm open to questions if people want to just pop in as I'm going through, but at the same time, I realize we have a little bit of a time crunch, so I'm going to move through this, and then I guess we're going to take questions at the end. Is that right, Heather? Well,
Mark, you're welcome to take your full hour, excuse me. And we've been using the chat box primarily for questions, although Tim or I may interrupt you if we see something kind of relevant and timely coming through. But if you're okay with people just jumping in, we're okay with that too.
I am, just because sometimes we'll go down a path and it's easier to clear it up. And if one person has a question, there's probably a good chance that there's more than one person having a question. And so, again, I'm happy to be invited to talk to the NRCS. Nutrient is a company that I have to get to the point where I'm actually advancing my slides here. Nutrient is a company that was actually founded by the dairy industry itself. The dairy industry, the co-op members, felt that there needed to be a entity that could actually work with the dairy producers on farm to help them understand and identify how they could address environmental issues. And so since Nutrient was founded, something like 6.5 years ago, the opportunities have always been there, and we've always been delighted to work with NRCS. And so one of the things that we've always done is to try to develop strong relationships, with NRCS wherever we work. Our priorities are generally energy usage and generation, nutrient use through innovative technologies, and then ecosystem service markets. And so this is basically what I'm going to try to talk a little bit about today. Give you a little bit of an overview of kind of where things are on the markets and what's kind of driving the interest in some of these energy usage and generation opportunities, talking a little bit about what some of the forward-looking opportunities are, and then talking a little bit about the ecosystem services marketplace. So one of the things that we would like to see and what we see happening now is we see that, currently there's a lot of increased, regulatory pressure. There's innovative technologies that exist that aren't economically viable, and there's consumers that are very attentive and they trust agriculture, but they really want to know more about it, and they really want to see sustainable agriculture, not just what is commonly called greenwashing, but actual production and actual results that can be pointed to. What we would like to see is positive environmental improvement, and then improve economics to support those technologies that we have available, and then to help people see dairy as a solution, not as part of the problem. So the industry has done some assessments, materiality assessments, and if you'll notice the red circle on this slide, you can see that there's a lot of environmental issues that are significantly important to our consumers. And so, greenhouse gas, water quality, water conservation, energy use, the soil has become a real intense topic here over the last couple of years, and the ability of the soil to sequester carbon. And so nutrient and the dairy industry is involved with all of those areas and trying to make sure that we are staying ahead of the curve and identifying those opportunities for dairy producers and others to be involved and to really continue to move the needle in a positive direction when it comes to being a solution to these problems. Dairy's footprint actually falls down into about 4 different areas. We have feed production and practice changes related to producing the feed for the cows, and that represents about 26% of the greenhouse gas footprint, carbon footprint of a dairy. Then there's the cow care and the efficiency and the actual milking of the cow, and that actually has about 34, almost 35% of the greenhouse gas production, and that's generally enteric production. That's the production you hear about cows belching and releasing methane. And so there are a lot of issues related to these enteric emissions. We are really working hard to find feed additives, management practices, and optimized rations, and even the genetics of the cow are now being investigated to find those cows that have less enteric emissions and higher production. And so as an industry, we're actively pursuing many different routes to try to reduce enteric production. Then there's, energy efficiency and renewable energy usage. Energy usage on the farm represents about 4.5% of the carbon footprint, and doing things, which NRCS has really identified in their practices and things like that related to energy efficiency is very important. And so we continue to look at that, and then we also look at where are the opportunities for us to engage and produce renewable energy, and what are the different, not only mechanisms to do that, but what are the markets that will support them. And then finally, manure handling and nutrient management, the topic that's near and dear to my heart, because nutrient dealing mostly with the environmental aspect on farm is dealing with manure technologies, and that's almost 33.5% of the greenhouse gas emissions. And there we do have technologies. Many of the technologies that already exist in wastewater treatment is available to work with dairy manure and the dairy industry. And where the treatment technologies are used in wastewater treatment to treat concentrated sludge, so that you get a lot of water in a municipal plant, you pull the sludge off, and then you treat the sludge. In a dairy, almost everything comes in at the consistency of the sludge that you create in a wastewater treatment plant. So I always tell people that we are like the back end of a wastewater treatment plant, because we don't have to deal with as much water, but we have to deal with a lot more concentrated product. So as we look at the opportunities, one of the big opportunities right now is biogas production and renewable energy production. And so what I wanted to share with you and what I want to take you through is some of the reasons for that and how some of those markets have developed and what's going on in them, so that we can have conversations around what are the important issues as you're communicating to farms and farmers, that you can help them understand if they're asking you questions. And I want to preface this with, I'm not trying to make you an expert, and I understand you're going to get questions, but I'm happy to take questions from dairy producers. And so if you ever do have an opportunity where somebody's saying, hey, have you heard anything about this? Feel free to send them my way, because they really are the people that fund Nutrient. And so I work for the dairy producers, and I'm happy to work with producers of any size, really anywhere in the United States, to be able to have conversations around what can they do, what kind of conversations should they have, and really where are their opportunities. So as we talk about biogas, the U.S. dairy industry is a powerful environmental solution. We can provide solutions. We can reduce our own emissions, but we can also help offset other emissions. So as we look at the environmental benefits of dairy, we can see that we have real opportunities, and if there are sustainable long-term markets, there are ways to pay for those benefits that actually help the society to reduce the overall greenhouse gas footprint. There are companies right now that are actively partnering with dairy farms to put in anaerobic digestion and to lower greenhouse gas emissions. And that provides a diversified revenue stream to the dairy producers. So now they're not just trying to support their family and their farm on the milk and the milk price. They're also getting renewable energy prices that's not really connected to the milk price, that gives them an opportunity to actually see revenue streams that aren't necessarily always going to go up and go down. One of the unfortunate ironies of being in the dairy industry before was, when everything was related to the cows, if milk price went up, people added cows, and so cows became more expensive. And so as your price moved up, your inputs moved up. And then when prices got too high and people started to sell off cows, then the prices of cows went down, and you couldn't make up for the lower price, the lower prices in milk when people sell off cows. You can't make up for those lower prices by the other revenue stream, which is sale of cows, because their price is depressed. Renewable energy doesn't tie with that cycle. So the cost of electricity, the cost of renewable natural gas, the cost of those sort of markets aren't tied to the cycle of milk production and milk sales. And so you may have milk sales being really, low, and then the price that you're getting for your milk being low, but the price you're getting for your renewable electricity being high. And that can support a dairy, through times when maybe the milk market isn't as good as it could be. So by the numbers, we see that right now there are about 234 anaerobic digestion systems processing dairy cow manure waste in the United States. They right now produces about 2.5 or 6.5 million metric tons of CO2 a year, and there are currently about 50 more either in planning or in production or that have gotten grants. But the potential for AD systems, if we were to adopt AD systems in America like they have been adopted in some of the European countries like Germany, is over 2,700 additional dairy farms and almost 30 million metric tons. And so we really have an opportunity to expand this and to work on this sort of scale if there's markets there to support the technology. Dairy manure is one of the largest sources of methane from livestock manure management, and it's also one of the largest sources of renewable natural gas. There are about 1.2 million metric tons of emissions from dairy each year, and those emissions in a large part could be offset by AD, and instead of those emissions contributing to global warming, they could be offsetting global warming, because as you capture the methane that would go into the atmosphere, that's a direct benefit. And then as you use that methane in the transportation industry or to replace fossil natural gas, that's another direct benefit. And so you actually get to legitimately double dip, because you're reducing greenhouse gas emissions into the atmosphere from the manure lagoons, and you're reducing greenhouse gas emissions from fossil fuels. And so it's an opportunity that we really can see benefit to the climate and to the environment. Here's a map of where biogas systems are in the United States. Kind of interesting, as you see, there are starting to be a significant number out west in California and up in Oregon and Washington. You know, part of the reason for that is there's a lot of cows out there, and part of that reason is the market is out there for the low carbon fuel standard, and the California Air Resource Board is really incentivizing and providing significant funding to help establish anaerobic digesters on dairy farms in California. You'll see there's a lot of other ones as you move to the east, generally where the cows are. And interestingly enough, there's a bunch of really small ones up there in Vermont, because that's where the best market is for renewable electricity. They have a program called the Cow Power Program that actually sells electricity from small dairy digesters at about 22 cents a kilowatt hour, the little bit bigger ones at 18 cents a kilowatt hour. And that becomes a market that then supports those generation projects up in Vermont. So on a per capita basis, and I think a per cow number basis, Vermont probably still leads the United States in the percentage of digesters per number of cows. Again, talking about that potential, there's a potential to generate, you know, over 9 million megawatt hours a year, or 100,000 million BTUs of renewable natural gas per year. And one of the interesting things I did back here a few weeks ago was I went back and I looked at the life cycle assessment of the dairy industry, and I reached out to Greg Thoma, the professor at Arkansas State University, and I said, where did you get all the numbers for, you know, the processing numbers and things like that? And through getting those numbers, I was able to go back and take a look at, you know, the 2017 digester numbers and the 2017, you know, herd size numbers, and then the 2017 processing numbers. And a really interesting thing that showed up was, and this is just kind of a logic exercise because it's not practical to do right now. It's not affordable. But if you could take every dairy that had more than 50 cows, and you could capture all of that through anaerobic digestion and convert it to energy, both renewable electricity and renewable natural gas, the dairy industry could produce enough renewable natural gas to supply 100% of the processors' needs and 80% of the electricity. And so with a little bit of food waste added in, we could probably take care of the transportation sector and the retail portion as well. So as an industry, we do actually have an opportunity to significantly reduce and address the impact we have on the environment. And it gives us a real opportunity as we look at regenerative agriculture and carbon sequestration to truly be a net negative impact industry that many other industries just don't have that opportunity outside of forestry and agriculture. And so it's again, not necessarily something that we could practically do right now, but it does show the potential impact that we could have as an industry if we were able to actually find markets for all of those projects. So what's actually driving this interest in dairy biogas? Well, number one, there are state and national incentives. state incentives like the low carbon fuel standard, which is available in California. It's passed in Oregon. There's also New York is looking at them, the state of Washington, New Mexico, Minnesota. A lot of these are geared toward getting renewable fuels into the transportation sector, as is the National Renewable Fuel Standard. And the National Renewable Fuel Standard is what most people know as the ethanol credits. But it also includes other credits that are made from cellulosic materials, and by definition, that's what dairy manure is. And most of those D3 is what the designation is for those credits. The D3 RINs are actually being produced either by landfills or dairies that are producing renewable natural gas from manure and landfills. And so those are two of the really big drivers that we see right now. States are competing for, are eventually going to be competing for the different sources of renewable natural gas. The national program stacks on top of the state program. So you get a national incentive for going into the transportation sector, and then you actually get a state incentive for going into, for example, the state of California's low carbon fuel standard. The national program is not tied to the carbon intensity, but the state program is. We're going to talk a little bit about that as we drill in a little bit deeper here. But as we go on, another thing is that there are a lot of companies, both in the dairy supply chain and outside of it, that are setting aggressive carbon reduction goals. And many companies, for instance, those that are in the EU, are being driven by requirements in their country, but some of them are simply driven by their investors and their investor groups. And so we see a dramatic increase in the number of companies that are looking for renewable energy or renewable credits, carbon reductions that they can tie to their supply chain. And that's one of the things that dairy is trying to offer its vendors now, or its customers. Now, one of the things that is somewhat difficult is the customers are coming in saying, well, we want our milk to be low carbon. Well, if the milk is low carbon, that means we can't sell the carbon credits, because when you sell a carbon credit, you're actually sending the credit for being low carbon to whoever you sell it to. And if those customers in the supply chain aren't willing to buy those credits, then there's no way to support these projects. And so right now we're kind of in a bit of a dilemma where we have to, if we want to support the projects, which are good projects from an environmental standpoint, we have to go outside of the supply chain many times to be able to realize the revenue that supports the projects. And that's something that the industry is working with right now, and it's something that we are really trying to come to grips with and make people aware of. Another thing that we see that's moving energy projects, and some of these are actually driving the projects themselves, are gas utilities that are looking for renewable natural gas to improve their portfolio. And we have actual natural gas utilities that are building projects or that are engaging with projects to buy the biogas simply to reduce their carbon intensity, so that they have the ability to look at the gas that they're supplying to their customers that might be interested in low carbon or low impact gas, or that they might simply be able to lower their carbon footprint as an industry. And so we see that also being a part of this drive to develop renewable natural gas projects. In some areas, we're seeing some increased regulation. Fortunately, USDA, EPA, many of the, even California, there is an opportunity to regulate, but they're trying to create these voluntary markets first. The difficulty with regulation is once you regulate, you take away the ability to generate the credits and the revenue to support the project. And so very often, if the knee-jerk reaction is simply to regulate, you simply put out of business many of the people that you need to produce the product and to support the projects that benefit the environment. So fortunately, here recently, we've been seeing a more market-driven approach rather than a regulatory approach to lowering greenhouse gases. But the final success of all of these will be, can we establish long-term markets? Because if you don't establish a long-term market, you end up in a situation like Oprah had when she gave everybody in the audience a car. You've given them something, but if they don't have the money to pay for the taxes and the insurance and the tires and the gasoline, they don't have a way to use what you've given them. And too often we see digester projects that originally were started with good markets and then the market changed. This happened to almost all the digesters about 15 years ago, where they were being built for electrical projects, getting 10, 12 cents a kilowatt hour. And then because of all the solar and wind projects that came on, the actual value of the electricity went down. And instead of getting 12 cents a kilowatt hour, people were getting 3 and 4. Well, it costs 5 cents to run a natural gas engine on biogas. And if you're doing that, you haven't even paid for the digester yet. So you're already losing 2 cents just running the engine, and you haven't started to pay for the digester yet. And so this fact that there aren't those long-term markets really actually we started to see a decline in the number of anaerobic digesters in the United States for a few years. I mean, it wasn't significant, but there were a few more being shut down than were being built, in 2016, 2017, 2018. We now see that reversing because now there's another market, and that market is renewable natural gas. So this is how it works for dairy projects. First of all, dairy projects don't just work for the most part, on the energy side. Yes, you can get a good amount of revenue from the renewable fuel standard, and that will support some projects. But for most projects, especially as we start getting into smaller dairies, you're going to need energy, environmental credits, manure-based products, and maybe even some tipping fees and things like that to help projects really cash flow for these smaller dairies. And part of the reason for that is manure really isn't that great of a feedstock when it comes to producing renewable natural gas. If you think about it, the cow got the first opportunity to get the good energy. And she took advantage of that in a mechanism that in her gut is very similar to what happens in an anaerobic digester. So if you're just digesting dairy manure, which most projects are because it qualifies for the higher value RIN and the higher value carbon intensity score, you don't get a lot of production per volume of solid that you put in. And so that tends to make projects have to look for other opportunities. And that other opportunity is the reduction of the methane from the lagoon, and also the offsetting of the transportation fuel. And this is where the carbon intensity score and the low carbon fuels standard comes in. This is a California equation program that produces a credit. The credit is based on what they call a carbon intensity score. And so it is looking at how much you reduce the greenhouse gas impact on the environment as the whole project. And in the lower right-hand corner of the slide that's on your screen, you can see a conceptualized CI calculation. And I say conceptualized because this is like at such a high level that it's almost useless for anything but a way to kind of wrap your head around the way the calculation works, because it's multiple pages of data that have to be analyzed to get you to a CI score. But essentially what it does is it looks at a farm where a project's going to be put, or any project for that matter, and it says, what are the current emissions from everything involved in that operation that will now have a renewable energy project? And then from that, it says, what emissions are we going to eliminate? So what emissions from the farm are going to go away? And so from that baseline that's 0, for example, reducing farm emissions is going to be a negative number. And so in the case of the dairy industry, it's a pretty significant negative number because of the methane released from lagoons. And then the next part of the equation is, when we use this methane that's produced as renewable natural gas in the transportation sector, how many emissions are we going to reduce in that area? And so that's basically replacing the fossil fuel renewable natural gas or the fossil fuel diesel with renewable natural gas from this renewable source. And that's another negative to the project. And then the final thing they say is, now to be able to do this, we may have to use some fossil fuels, or we may have to create some greenhouse gases in this process. Maybe it's hauling material to the digester, maybe it's heating the digester, it might be transporting the biogas to the injection point if you're using a virtual pipeline. So then you take all of those greenhouse gases and you add them back. And the final greenhouse gas intensity score is what you have, and then you use a calculator that's produced by CARB based on your greenhouse gas intensity score and the price of the credits to determine what your price will be per million BTUs. And you can see on the right-hand side of the graph, a typical Midwestern dairy that's putting their manure into a lagoon and storing it, and then, you know, basically getting it out on the fields a couple of times a year, but maybe not getting it all out there, is going to have a CI score around the minus 250, 255 level. Now, again, if there were a way to put a solar farm on there and offset their electricity, my understanding is that can reduce that intensity score by another 50 points or so. If there were a way to get a solar heating system to produce the heat for the digester, that would be another reduction. And so there's all of these different opportunities and all of these different companies that are looking for ways to lower the CI score and therefore increase the value of the renewable natural gas. So what does that mean? What does that mean to a project? Well, natural gas is sold by 1 million BTUs. 1 million BTUs is a standard unit, sometimes called a decatherm, a standard unit of sale. And so right now, and I based all of these numbers on Monday's markets. So right now, if you have a renewable natural gas project in that minus 250 CI score, you could sell your gas for about $89.79 per million BTUs. The base gas price, what you would pay for a 3-year contract for base gas right now on the CME, is about $3.50, $3.59, which means that the base gas only represents about 4% of the price you get for the RNG. It also means that the gas is being sold at almost 25 times the value of the base gas. And the value is about 44% from the national program, the D3 RIN value, which is about $39.35 of the program, and 52% by the low carbon fuel standard credit. And that's the $46.85. Again, that D3 RIN is from a cellulosic feedstock, and that LCFS credit is based on that minus 250 score. So if you're not selling, if you're doing a food waste project, you're not going to get a D3 RIN, you're going to get a D5 RIN. That's worth about half of the amount that a D3 RIN is. If you're doing that same sort of project, your CI score is going to be much less, maybe minus 50 instead of minus 250, and that's going to significantly reduce that LCFS credit. But this is a big reason why there is so much interest in the dairy industry. And the next slide I'm going to show you is kind of where the opportunity is, and this is what I try to really talk to dairy producers about and help them understand. Number one, that they're already spending money on their manure, and that they need to understand what that money that they're spending on manure is. Before they get involved in a project, you've got to kind of know where you're at, because one of the things that you're going to have to do as part of negotiating or considering putting in a project yourself is to consider, what's it going to do to my manure cost? Is it going to make it go up? Is it going to make it go down? You know, what benefits am I going to get? What costs am I going to incur? And right now, looking at costs in 2019, if you were in that same typical Midwestern dairy, scraping to a lagoon, you know, having a lagoon filled where you're emptying it a couple of times a year, a well-run operation is going to be somewhere between 50 cents and $1 per hundredweight, or right in the neighborhood of $200 per cow per year. Now, if you're working with a digester company, I think it's reasonable to say if you're going to benefit from that manure and from me collecting that manure and delivering it to you and then taking the manure after you're done with it and taking care of it, you should at least share in some of that cost. And so from a negotiating standpoint, knowing this number gives you an opportunity to go to it as a producer, to go to a developer and say, here are what my costs are to move manure now. And you want me to change that system, maybe make it less efficient, and you want to profit from this. So I think you need to help me cover some of this cost as a base. And then let's look at how much revenue you can make based on the slides that we just had before in a project, and what can that mean to us if we work together over the long term. So first of all, if you take a cow, and I wouldn't suggest doing it for one cow, but if you have a large number of cows and build a digester and heat it and operate it properly, you can get about 100 cubic feet, 100 to 115 cubic feet of biogas per cow per day. And that equates to about 21 million BTUs per cow per year. And so that same million BTUs that you see on the left-hand side is now worth almost $1,900 on an annual basis for your cow. And that $1,900 times 21 is the revenue that you're going to get for a project. And so when you look at that revenue and you say, well, what's a reasonable way to share that revenue? What I propose is a developer who's coming to talk to a producer should consider what his costs are. And so covering half of those manure costs seems reasonable to me. And then a producer should recognize that the developer is taking most of the risk and investing most of the money. And so there's a point where they need to be able to cover their costs, which are about 37% of the total revenue. And so when you get to that point, say $40 an MMBTU, for example, they really can't afford to pay you anything more than that, cover that manure cost. But if you move beyond that point, say get to $80, between $80 and $100, then it doesn't seem unreasonable to ask for 1 MMBTU's worth of value over the course of a year. If they move beyond $100, between 100 and 120, maybe it's reasonable to ask for 2 MMBTUs. But that's all negotiable. And truly, as we go out into the industry, we see that there's an awful lot of this that is negotiable. And so as we look at these opportunities, this is kind of where I tell producers, give me a call, have a conversation with them, show them these same slides, and explain to them that here are the opportunities that are available for you. Excuse me. So what do they have to consider? And as you're thinking about these type of projects, what do you need to help them consider? Well, number one is, how are these type of projects going to affect the dairy's operation? You know, what's it going to do to their bedding, their manure recovery and manure management, how they utilize their nutrients, what limits are there going to be, what's it going to do to their labor, permitting, scheduling, traffic on the farm? What do they need to look at in that respect? And then the second area is more the long-term area, is what's it going to do in the future? This is a long-term commitment. I looked at a contract today where when you put all the pieces together, the contract tied up the dairy with a developer for 30 years. There were a couple of options, but the contract could go out 30 years. So you want to make sure you have a contract that's flexible enough and that's fair enough that 5, 10, 15 years down the road, you're not kicking yourself because of that contract. So that's something you really have to consider. And then you have to consider who's going to be running this dairy 30 years from now. I can tell you right now that if I was a dairy producer 30 years from now, I would not be running the dairy because I would not be able to run the dairy in all likelihood unless I live well beyond the life expectancy of a male in the United States. So who are the people that are going to follow you, and are they on board to do this? And are they on board with this relationship? And what opportunities are you going to miss? And what expertise do you need if you're going to try to do a project like this? Or what expertise do you have to hire if you're going to have somebody else do the project and you're going to invest in it? And then finally, what is your capability of investing in this? And then as you look at it, you've got to look at all of your costs and all of your values and kind of put everything together and do it comprehensively. Don't, again, I've looked at contracts where the agreement is for a biogas project, and somewhere in the agreement it says that the developer gets all the environmental credits resulting from the manure. Well, if you're just building a biogas project and you can get somebody to give you all of the credits that might be developed in the next 30 years for that product, that's a good deal, but it's not really a fair one to the producer. And so those are the sort of things that I really encourage people to do their due diligence, have conversations, reach out, have people that understand contracts, take a look at it, make sure that you are watching out for yourself and the future of your dairy. So I want to cover a few other things real quickly here as we wrap up before we go to questions. And number one is I want to talk a little bit about the electric pathway because it offers an opportunity for the smaller dairies to produce electricity. You really need a larger dairy, probably in the neighborhood of 3,500 cows, maybe 2,000 you could get away with if you were in an area where you could get a good interconnect to a utility. But it's difficult on a smaller project to be able to cover the cost of cleaning the gas and injecting it into the pipeline. It's much easier to flow electricity back onto the circuit. And right now, in the United States, only about 17% of the energy that we get is from renewable sources. The other 80% or more are from nuclear energy and fossil fuels. And so as people are looking at the opportunity to buy electric vehicles and to electrify everything, as you hear some people say, there is this disconnect that people don't understand that's actually going to move us to be using potentially more fossil fuels than we're using right now. And so one of the goals is to get the renewable fuel standard to actually reach out and address this through what they call the ERIN pathway or the electrical pathway for the RFS. This has been part of the legislation since it was passed 14 years ago, and 7 years ago, the EPA actually did some information outreach and rulemaking outreach to talk about how to get it in place. But even though we know there have been about 40 projects submitted to EPA, at this point, none of them have been approved. And so there isn't an opportunity for people to really realize that. And so we're not able to see zero emission vehicles because the emissions are just moved to the power plant. And so as we look at it from the dairy industry standpoint, Nutrien is trying to actively engage and activate this renewable electrical pathway through the renewable fuel standard. And a really interesting thing about renewables that I always like to throw in, this is a really old slide, it's from back in 2008, but it's really interesting because for all of the tax credits and all of the incentives that wind and solar have got, they both only operate part of the day or part of the time. And anaerobic digestion, because of the way cows produce our feedstock, is operating all the time. It takes about 21 days for the manure to actually completely break down. So as you keep adding manure all day long, every day, 365 days a year, the digester keeps running and you just keep producing renewable energy. And so we are actually making some headway in Congress and in other areas in helping people understand that this is an opportunity that needs to be incentivized, and incentivized with those type of voluntary markets that have driven the price of wind and solar down so much, to let us have an opportunity to be as competitive as they are. The last area I'd like to talk about is just a little bit about these future opportunities in ecosystem services. Dairy has some tremendous environmental assets. They have the ability to stack a lot of credits. We have a lot of different places that we can address things. And there are a couple of different types of markets. There are voluntary markets that are just driven by environmental goals by companies. And then there are regulatory compliance markets that are driven by somebody being regulated. The RFS is a regulatory compliance market because the fuel industry is obligated to buy these credits. And so those compliance markets are out there. But one of the things we're really seeing in the carbon world is a development of opportunities for carbon credits for regenerative and sustainable agriculture. One of the difficulties is the protocols and the programs are not fully developed, and they're really not completely in place. And you don't know what you don't know, and you don't know what the market's going to look like. And so what we've been encouraging people to do when it comes to these other markets is just tread lightly when it comes to those areas. Don't sign up for a 30-year contract on a soil credit when 3 years from now there may be a completely different crediting program. Use real caution when evaluating the solutions and really think about the impacts it's going to have on your operation. Keep your options open. There's going to be a lot of opportunities over the next 3 to 5 years, it appears, and we really, as an industry, need to take advantage of those opportunities. But at the same time, we need to stay flexible. And then finally, stay very curious and stay engaged and learn everything you can about those opportunities that you can diversify your operation beyond just producing milk. And so that's kind of the takeaway message that I leave with dairy producers, and that I would encourage you to leave with any producers that you speak to, continuing to do your excellent work at helping people to address the environmental issues and working with them on the farms and things like that. You're the people that really rub shoulders with the people on the ground. And as you're having these conversations, absolutely feel free to use Nutrient and my contact information that I've provided to Heather and others. Feel free to have dairy producers give me a call whenever they have questions. And speaking of questions and opportunities, here are the resources that we have available. Nutrient.com has a catalog of technologies. We are expanding that catalog. It's a little stale, but by hopefully the 4th or 5th of next year, we're going to have a whole new platform to work from, and we're going to be able to move that forward. You can contact us by phone. You can contact us by email. My email will be provided at the end of the presentation, and Heather has that. And then we do present a lot of informational webinars, and we have blogs on our website and things like that. We encourage you all to sign up for those. There's actually a 4-part series that was sponsored by EPA AgStar that talks about renewable natural gas projects, how they work on the farm, how to choose partners, how to finance and get the permits and the contracts in place, and then actually what happens when you break ground and start to move forward. That's all available on our website. You can go there and you can actually view these. Again, we're paid for by the industry, so there's no subscription. There's nothing. When you go to the catalog and it asks you for information, it's simply so we can send you information as part of our our outreach. There aren't any other costs. And so at that point, Heather, I'm going to open it up to anybody who would like to ask any questions. And I'm going to turn off the question slide. I will leave this up here real quickly for people for a couple of minutes, just so that you can see this, and then I'll shut down the screen sharing, and we can go to questions and answers face to face if people want to do that. But are there any questions that are hanging out there that I need to try to clarify any points or?
Thanks so much, Mark. We have one question that came in through the chat box. And the question is, what are the best BMPs for small dairies, like speaking of 40 to 80 cows in Pennsylvania, to reduce their greenhouse gas emissions? And then as a follow-up, are there any, or are they below the baseline cost benefit ratio?
Is it for, so I would say the BMPs for all dairies start with anything you can do to maximize your production and to feed your cows better feed. And the reason for that is there really isn't anything that drives the greenhouse gas emissions per pound of milk down faster than increasing the amount of milk you produce. The cow has essentially got a base amount of metabolism that she runs and produces enteric methane for. And as you produce more milk, that base doesn't get bigger. So now you're producing milk and you're only getting a smaller portion of greenhouse gas produced. So anything you can do to improve feed quality, to improve cow comfort, to improve your production, to maximize your herd health, to improve your genetics, that's going to have the most bang for the buck. Other things that can affect it are things like no-till, strip-till. Those are sort of the things that will help. Things that sound as silly as making sure you're kernel processing your corn silage so that those corn kernels are actually cracked, and when the cow eats the silage, she's able to get the energy. I jokingly tell a story about when I first started working for Nutrient, and I was starting to visit farms, and I would occasionally visit farms, and I'd ask them what they bedded on, and they'd said they bedded on sand. And I'd ask them if they had a sand separator, and they said, yeah. And so I'd go take a look at it. And I quickly realized that the farms that don't use kernel processing actually don't bed on sand. They bed on a combination of sand and corn kernels, because it comes right through the manure as a kernel, and it ends up being captured by the sand separator, and that ends up in their bedding. And so you're spending a lot of money to grow a high quality forage and corn. And if you're not using kernel processing, you're not getting the nutritional value for your animals that you could get simply by making sure that that one piece is added to your corn harvest. So anything that increases production, at least for the smaller farm, is going to be important. Anything that makes your cows able to produce more or eat less because of nutritional value or whatever is going to be your best investment. And then, of course, energy efficiency, things like that. All of those sort of things, as we look at from an NRCS standpoint, the nutrient management plans, really managing your manure in a way where it doesn't spend a lot of time anaerobic, or using the solids, getting the solids out of the manure and getting the solids into something like compost where you're aerobically treating it can be beneficial. And again, a smaller farm can do that. It doesn't, you don't have to be a big farm to be able to do composting. There are other NRCS practice standards that are out there that can actually positively benefit a dairy. LED lighting, upgrading your vacuum pump, all of those things that reduce your environmental footprint and also at the same time reduce your cost. The more efficient you are, the less it costs you. I've used the illustration before. You know, there's one way to get money is to get revenue. Another way to do better is to keep revenue or avoided cost. And so if you don't have to spend money and it stays in the bank, that's just like being paid for it. So putting in LED lights the next time you change out light bulbs, or looking at LED lighting in your barns instead of high intensity fluorescence, that's an opportunity for many dairies. And it's an opportunity that they can work with NRCS to put programs in place to help get credits, sometimes from their utility, sometimes directly as part of the EQIP program.
You know, Mark, I really appreciate what you just said there, because we're so used to going the bioenergy route, and thinking digesters, incineration, things like that are the way to go, which often are cost prohibitive for our smaller scale operations. So for what you're saying, the no-till, the feed management, back to the basics of true conservation, is so important to hear. And it's good for us to hear, to remind us that the simple things, the energy efficiency, working with our conservation planners, to be working with the landowners to make sure the landowners are doing the little things. They don't necessarily have to do the big things or be able to afford the big things to still make a big impact on their operation. And
they can get credit and they can get EQIP funding for a lot of the little things. And I mean, one of the little things that I would tell people, and you've got such a beautiful creek there, and you know what makes that creek behind you even more beautiful? There's not one cow standing in it. It's a pet peeve of mine. You see people who have these sustainability programs on a dairy, and they've got this beautiful picture of cows out on the pasture, and they're standing in the creek. And I'm like, guys, we're trying to keep nutrients out of the creek, and you've got the cow standing in it. Those are just common sense things. Riparian buffers. Doesn't have to be a huge buffer, but don't let the cow walk in the creek. Collect the manure. Don't let it run off your farm and get into your waterways. The more you collect, the more you can use to offset what's now becoming really expensive fertilizer. These are opportunities for you as a dairyman to have an avoided cost. And then you don't have to worry about the neighbors complaining about the creek looking the way the creek might look if there's too many cows in it. So take advantage of those opportunities. And the other thing that there's always been this kind of, should I work with USDA? Should I work with, what if I have people on my dairy and they see things? Let them see things. Let them help you. Have a conversation. It's okay for somebody to point out something you're doing wrong. It may help you. If you're trying to do things right, in the long run, having conversations with people and having conversations that will improve your operation is for your benefit. And so that's what I try to tell people is, don't look at these resources that are actually there to help you as being a negative because, well, I don't want to work with any government official. That's not necessarily in your best interest if there's programs out there that can help you get better, that can help you be more profitable, that can help your dairy be more productive for the next generation. I'm trying to say you are the good guys.
We appreciate it, Mark. Maybe you should come join our side. But now,
I don't know. I just hired somebody from your side to come work on my side. So.
Well, hey, we appreciate it. I don't see any other questions in the chat box.
Please please send people my email, and please feel free to reach out and contact me or pass my email on to producers that you might know. I'm happy to answer questions, and if there's too many of them, we'll have another webinar. How's that?
That sounds great. Hey, what I will do is I will put your email in the chat box. That way everyone has access to it. And then with that, I think we are going to quickly switch gears and I am going to turn it over to Tim Peters for an NRCS programs update. And Tim, I'm going to let you introduce yourself. That way
Yeah,
we don't
I'm
have to
going to say
spread-
thank you one more time, and I'm going to leave.
Thanks so much, Mark. It's very much appreciated.
Take
Thank you,
care, all.
Mark. All right, thanks a lot, Heather. I appreciate that. Heather asked for bios, and I failed to give her one, so that's on me. And I don't need to say a whole lot, but I did start with NRCS as an intern in Bloomsburg and bounced around the state a little bit. Worked in the Bloomsburg Tech office for years, and then Somerset, and served as area engineer for the West and Somerset and Clarion areas before moving to the Harrisburg office here, where I am today. And correct, I'm going to turn my video back off now, but for those that don't know me, give a call sometime and I'd love to chat. I did want to give a quick programs update, and what I'm going to focus my talk on today. Can everyone see my slide? Or can somebody see my slide?
Yeah, you're good, Tim.
Thanks. So what I wanted to focus on, though, for most of my talk today is the cap transition. And I'm going to apologize right now. We saved the least exciting presentation for the very last talk. So
Well,
it's
hey,
not.
Tim.
Yes.
Sorry, you are not the least exciting, but we can see your full PowerPoint. I didn't know if you wanted to put in presentation
Oh yeah,
mode.
let me switch that. How's that?
And if you need a couple like snowman jokes or something to liven it up, just cue me and I'll be ready.
No, let me. I've done Teams enough that I should be able to do this. I'm going to stop presenting and try presenting my my correct window here. Bear with me one second. How's that look?
And it's still coming up.
As
But it's trying.
is this oh, okay, still okay. All right. And if I have to switch to my PDF, I will. I don't have any pictures, or very few pictures, except for on the cover page here. So
I saw someone give a thumbs up, so I think you're probably good. There you go.
okay, very good. So what I wanted to talk about was the cap transition. And some of you may know, some of you may not know, but caps, historically what we called caps, are conservation activity plans, have changed. They have been revised by the National Office for this year. And they are caps are plans that were developed by technical service providers, our TSPs, who are consultants who are registered with NRCS in our NRCS registry. And the most common cap plan that we used historically that involved engineering was the Comprehensive Nutrient Management Plan, the CNMP plan, the 102 plan. And so that's what I want to talk about. And many of the slides that I'm going to show today are ones that I stole from a national presentation that updated me on this transition. So the transition has started. It's happening this year, and I just want to give a heads up to everyone. Now, I will preface this talk by saying that this is a little bit of a work in progress. I do expect there to be some changes and some kinks to work out, and we'll do that. But I think it's going to be a good change and a good transition in the long run. So the transition is a 2-year process. National is planning on this taking 2 years. And like I said, I think there are going to be some problems that we need to work out. But I will share with you what I know today, and I will focus the talk today on the engineering side of things. So what was done? Well, nationally, they took the cap plans and they reorganized them into 3 different categories. And they are the CPA, Conservation Planning Activities, DIAs, Design and Implementation Activities, and SEMAs, Conservation Evaluation and Monitoring Activities. And nationally, they established a consistent format for all of these. And all of them now have a specific definition, criteria, deliverables, and references. And the goal of that being that hopefully there would be a better consistency from state to state across the country. Now, this slide gives a good and brief summary of what each of those are, but just to say what's on the slide, pretty much CPAs identify and assess resource concerns and determine alternatives to addressing them. The DIAs identify how to implement the CPA or NRCS developed I&E, and then the SEMAs would gather information to help with any stage of the process or to evaluate outcomes. And I'm going to hit each of those in much more detail as we progress through the slides. Now, this is a slide from the national presentation, and this really confused me the first time I saw it. But the point they're trying to make with this slide is that there are multiple paths to our end goal. And for example, I'm going to get my laser pointer here. TSPs, for example, could go through and do the CPA. Then the TSP could also do the DIA. And a TSP or another qualified individual could complete the SEMA. A similar path forward would be for NRCS to develop the conservation plan and for engineering the I&E. Then NRCS could also verify that I&E and move that project forward, work with the landowner to make a decision. And then NRCS also could play a role in developing some sort of evaluation or monitoring requirements for that project. And what the national slide likes to show is that this path could change. NRCS could do an I&E, and then maybe the TSP could do the DIA to verify the I&E and move it forward. Or the reverse, TSP could do the CPA, and then NRCS could move that I&E forward, confirm with the landowner, lock them into a decision, and then progress even further. Now, the thing that I found really confusing about this slide was that it's missing the engineering steps. The slide doesn't show where site-specific engineering designs and the construction would fall. And that would happen somewhere after the DIA. That would happen somewhere in this range right here. And we'll talk about that more. Before I get into the CPAs and DIAs more, though, I want to highlight the NRCS planning process. I think that'll be helpful. For engineering, our inventory and evaluations, our I&Es, would typically fall within the first 6 or really 7 steps of the planning process. And that would include identify problems and opportunities, determine objectives, inventory resources, analyze resource data, formulate alternatives, evaluate alternatives, and make decisions. I guess really the client is kind of making those decisions somewhere between the I&E stage and before the design stage. Construction and designs, well, designs would come before construction for the engineering projects, would happen usually in step 8. Agronomic or ecological sciences practices that involve IRs, they may happen in step 8 or they may happen earlier. And I just highlight that because that's going to be important when we talk about DIAs a little bit later. Okay, so the first item from the transition is the conservation planning activities, the CPAs. And these are activities that are typically performed in those first 7 steps. And we have the 102 Comprehensive Nutrient Management Plan, the 106 Forest Management Plan, the 116 Soil Health Management, the 138 Organic Transition, and the 119 Conservation Plan. I'm only going to focus on this 102 though today. I'm only really going to talk about the 102, the CPA 102, and the CPA 102 is really what replaces what we would know of as the CAP 102 plan from previous years. So if you're familiar with the requirements from the CAP 102, that's really what we're looking at for this CPA 102 here. The next transition item is the DIA, and DIAs, the design and implementation activities, they're new. This is something that is different, and these would typically fall around that step 8, implement the plan, at least for ecological sciences practices, and kind of fall somewhere after that step 7 in the NRCS planning process for engineering practices. Now, I'm going to say this a lot, and I've said it, and I'm going to say it over and over, but the DIA does not include site-specific engineering designs. I know the title says design and implementation, but it does not include site-specific engineering designs. They don't fall into CPAs, DIAs, or SEMAs. That's going to be something done outside of all 3 of those items. What I'm going to focus on later, though, is this 101, which it goes right along with the 102. Okay, Finally, the last category that nationally they've added are the Semas, and these would typically fall into step 9, where we're looking to evaluate the plan, but they're also telling us nationally that these Semas could be done at any step in the process if it would be beneficial to the planning process. So we may see these contracted earlier, we may not, and this is really something that needs to be fleshed out more from the national level. I think that's something that's going to come more in year 2 of the transition. A big distinction, though, to make between CPAs and DIAs and that of the Semas is that CPAs and DIAs require certified TSPs. You have to be a registered TSP with Nrcs to do a CPA or a DIA. And if you were registered and approved to do our old CAP 102 plan, then you have been grandfathered in. You're automatically approved to do the CPA 102. Semas, though, on the other hand, don't require you to be a TSP. They only require individuals meet the qualifications listed in that Sema. So you may be a TSP and able to do it, or you may not be a TSP and be able to do it. The thing that you need to do is meet the requirements of that specific Sema. This slide, I'm not going to say a lot, except that here's the link for the website, and more information can be found for each of the 3 types of documents, and it will take you to the National EQIP website. They have separate documents for each of the CPAs, DIAs, and Semas. Like I said, each document has specific criteria, and each document contains deliverables for the TSP or qualified individual to provide as part of that DIA, CPA, or Sema. Now, one thing that has to happen, and it's specific in each document, is that copies must be provided to the producer, to the Nrcs field office, and then also uploaded to the Nrcs registry. So that, I think that's a little bit of a change. That is a requirement. Now, I'm not going to spend too much time on this, but as for how these different items can be contracted, there's multiple options. CPAs, DIAs, and Semas can all be contracted separately, or they could all be contracted together. Now, it's my opinion that I think we are going to encourage CPAs and DIAs to be contracted together very regularly, very commonly. We'll see how that plays out, but I personally believe that the CPAs and DIAs will work best if they are contracted together and provided by the same TSP around the same time. Now, one limitation, though, one thing that we can't do is that we can't contract CPAs, DIAs, and conservation practices all together. And the reason for that is that we would need that CPA, our CPA 102, to first identify what conservation practices we need. So you can't contract those practices until you have the CPA first. And this slide's showing the same thing visually, so I'll just move on. Okay, so as I mentioned, the previous CAP plan, the CAP 102 in 2021 is now the CPA 102, and then added is the DIA 101. And I'm going to dive into the details right now. So I pulled pages from the CPA 102, and that's what I'm showing here. And I just wanted to highlight a couple different items from the 102 here. And the first thing that needs done is identify problems and opportunities. And this would require a site visit to document what is on site and what the issues are. And we are determining the objectives by discussing with the landowner what they want. What is their desired outcome? We need to document those discussions that are being held with the landowner. Also, inventory resources. What is the current management? What are the current soils? What is the site condition? What equipment is being used? What are some sensitive areas that need to be considered? All of the kind of things that we are typically doing in our INEs or CMPs, the engineering portion of the CMPs already. Moving on to the next pages, we need to formulate alternatives. At a minimum, the document says we need to consider at least 2 alternatives. The first alternative we need to consider is doing nothing. And then the second alternative we need to consider is addressing the resource concerns with conservation practices. Now, the alternatives need to be evaluated. So what are the impacts of each alternative? What is the impact of doing nothing? What happens if we don't do anything? And then what is the alternative, or what is the impact of moving forward with the project. What is the impact of designing and planning and constructing different conservation practices? And then these alternatives need to be presented to the landowner and that discussion documented. Now I'm going to skip over this. I'm skipping over some things because I want to hit some highlights. I'm going to skip down to deliverables, and the deliverables is continued on the next page here. So we need to document, actually, we need to have documentation of correspondence with the client, of any sort of correspondence with the client. And we need to document what their objectives were. We need to document what the interactions were, the site visits that were made, and the activities that were performed in the field. Additionally, it's required as part of the deliverables that maps or drawings include specific information, and that would be location of sensitive areas and setbacks, location of livestock production areas, location of areas that do not or do receive manure, planned and existing practice locations, and then soils information. We have to have soils information included. And then additional information that has to be part of the CPA 102, not necessarily on the drawings, but included in the package, is a list of the Nrcs conservation practice names and codes that are existing and then that are also planned. We also need to have the estimated planned amounts or the existing amounts need to be estimated. And then we need to have a brief description or narrative of what the project is and what we're proposing. Finally, we also need to have evaluations of existing waste handling or storage structures. So all those things need to be covered as part of the CPA 102. Finally, we need to have a description of the animal feeding operations, animal types, numbers, manure generated, capacity of storages, the storage duration times, animal mortality management, all those things that we're already hitting in our CAP 102 plans. Really, it's those same requirements just shifted over to a CPA 102. So it all should sound familiar, shouldn't be anything new, and TSP should continue with the same process they always have. They should continue to work with our area engineering staff, the processes that have been put in place with working with them, making site visits together, having the I&E portions reviewed, all of that still stands, and we should continue with that same process. Okay, so now maybe this does get a little bit more exciting. The DIA 101, this is the new part of the transition. And like I said, found this super confusing at first because they call it design and implementation, but it doesn't include the site-specific engineering designs. Now, it does include implementation requirements, or IRs. So if you're a TSP working on the CNMP, you do need to have IRs for the ecological science practices included. That is part of the requirements. But the engineering designs, those site-specific designs, they're not. They come later. So what is the DIA? Well, it's really just the next step after the CPA 102. The DIA 101 documents and verifies the previously developed CPA 102, or it could do the same for an older CAP 102 plan that was developed in previous years. Like I said, IRs need to be completed, and the DIA 101 needs to document the landowner's decision. What is the decision that they have made? Enough information needs to be gathered by the TSP to document that the CPA 102 plan is feasible and that the proposed engineering practices could be installed. And just so you know, I'm not lying about this, the last highlighted section here does state that for future planned engineering practices, the site-specific designs are not required to be completed as part of the 101. And they say it once again even. Engineering plans, job sheets, or implementation requirements for future plan practices are not required to be completed as part of the DIA. Deliverables. Similar to the CPA 102, correspondence with the landowner must be documented and then provided as part of the submitted DIA. If changes aren't needed from the 102 after reviewing, verifying with the landowner, discussing, the same maps, the same drawings can be used for this 101. If changes are needed, maybe landowner situations have changed, maybe site conditions have changed, then the maps and drawings need to be updated as part of this DIA 101. All right, continuing on with deliverables. The Evaluation of existing structures for integrity and feasibility must happen. We must look at the existing structures and determine if they are something that can be used. We need to gather as much information as needed to determine if the planned storages are feasible. And this is the big thing that I see impacting engineering as part of the DIA. We must, or the TSP must, include at least one soil test pit for storages. Test pits must be to a depth of at least 2 feet below our anticipated bottom of subgrade for our storages, and they must be 3 feet below if that storage is going to be in a karst or highly fractured bedrock location. Additionally, we want to see the soil from the test pit identified using the Unified Soil Classification System. The soil test pits have to be located. We have to show locations of where they are on a map. And I think the DAA actually says give 2 measurements from known points, but I think a GPS point could suffice as well to locate it. We need to show where wells or other setbacks and other distances to the storage would be. So we need to show that on maps. And even for storages that are above ground, we still have to complete a subsurface investigation, or the TSP needs to complete a subsurface investigation. It needs to be 2 feet below that planned bottom elevation. And then we need to document the environment that's been encountered, including high water table indicators, and then the soils using that USCS classification system. All right, charging ahead. And finally, on the DIA 101, evaluating the existing storages. So I mentioned that earlier, but it's highlighted again in the deliverable section. So to me, the DIA is essentially verifying the CPA 102. We're making necessary changes or additions to the CPA 102, and we're doing that so that the landowner has the information they need to make informed decisions and then be ready to move to the next step, which would be doing the designs after this DIA 101 is completed. The big thing that gets added from the CPA 102 to the 101, the big thing that's added in the 101 to me is that soil test pit investigation. That is a new requirement and something new that TSPs will need to do if they're doing a DIA 101. Since I'm talking about soil test pits, I wanted to highlight that in Pennsylvania, we have the PA3 soil investigation log for conservation practices. And I have the website listed at the top there, but you can get to that from the PA Nrcs engineering website. And I think this may be a useful tool for anyone that's not familiar with it, a useful tool to use as we're doing soil test pits. And the log, it has a section for a site sketch here. It kind of lists some things to think about as you're doing those test pits and the environment that you encounter or where it's at. It gives some guidance on classifying the soils you encounter with the USCS system. And then we have 6 separate tables where different test pits could be logged. And not required to be used. This isn't something that Pennsylvania requires for our engineering soil test pits, but it is a tool that you can use if you choose to. Okay, I also wanted to quickly discuss SEMAs, the conservation, evaluation, and monitoring activities. Like I said, I think there's a little bit more work that needs to be done or kind of hashed out on these, but a SEMA would support any step of the planning process. And the slide here says that, historically, the SEMA may have been included within a CAP plan, but for engineering, I feel like this is something kind of new for us. As I mentioned before, the SEMA itself, the document will list the qualifications that are required to complete it and that you don't have to be a TSP. TSPs could complete SEMAs if they meet the requirements, but you don't have to be a certified TSP. Here's a list of the SEMAs in place right now, and I'm expecting they're going to be adding a whole lot more over the next year and a half or so. But the 2 that jump out to me that may involve engineering at some point would be the SEMA 207, the site assessment and soil testing for contaminants activity. And this is really an assessment geared for soils in urban areas. And some work's being done on that. We're clarifying some things on that SEMA, but something that may come up down the road. The second SEMA that would could involve engineering is the Sema 228, the Agricultural Energy Assessment. And this is our previous CAP 128 plan, our Ag Energy Management Plan. So that is now a Sema, and it's the Sema 228. Okay, I'm going to shift gears big time here with my last slide or two, but I did want to say I'm sure many are interested in the fiscal year 22 payment schedules. My slide says that program staff will be posting these as soon as they get the approved version. Well, I went on to the website today through Photog, and through Photog I had to click on, it said the FA, I think it said the payment schedule for 2020, but when I clicked on that link, it took me to the fiscal year 2022 payment schedule. So that is posted. If anybody needs help getting to that, I can share that, but it's part of the equip page. And you're going to see that most of the scenarios that have been in last year are also in this year. There weren't a lot that were removed, and most of the items are remaining the same. Prices may have changed some to reflect price changes in the real world. Hopefully nationally they do evaluate those prices. Then we did submit some price considerations for national to approve, and some went through. So there are some price changes, but most of the scenarios are going to remain the same. What I did want to highlight is that there are added scenarios that are geared towards urban agriculture, and I list them here. I'm not going to say them all, but a couple that jump out to me that may involve engineering: the 317 composting. We have small farm composting pad and bins that was added nationally. We've got a micro irrigation systems payment that is much higher per square foot. The payments per square foot instead of acre, geared towards small farms and specifically urban agriculture. And there's a 558 for collecting stormwater, and then some additional practices that might support the irrigation. So these are new scenarios. The Pennsylvania Financial Assistance Program Manual, or FAP, that's still being worked on. Program staff are still working on that, and that's going to establish some requirements for these practices. There's going to be some limitations. It would be easy to greatly overpay for a micro irrigation system if we could pay for a couple acres with the payment per square foot that is now available. So there will be some criteria for using that, and that will be established here soon when the FAP gets released. But my take-home point there is that these are going to be available, and there's more to come on what the limitations will be for using them. And Heather, that's what I had. Any questions for me related to the CAP transition or payment schedule?
There are no questions for you in the chat box, Tim. Did you mention sending out the payment estimator spreadsheets, or did you want to mention that at all?
Oh, sure. So the payment, the cost estimator for incentive payments that is posted to the for NRCS staff, it is posted to the SharePoint, and that is on there, and it was also sent to the area engineers. So NRCS staff do have access to that cost estimator spreadsheet. That's all I'll say about that. If you notice any issues with it, let me know.
Tim, you did have one question come in right now.
Okay.
The CPA and DIAs, if contracted, will all be completed by TSPs only?
That's correct. All three of those, the CPA, the DIA, and the SEMAs, are only for TSPs to do. Now, NRCS has corresponding, we can do our own INEs. NRCS can do conservation plans, and that's always an option. Just like we've always done, there are times when NRCS would do the conservation plan and the engineering INE, and then the landowner would go out and get their own nutrient management plan. Or the landowner could go with that CAP 102 plan to accomplish the same thing. Same thing happens, it's just that they're using different terminology now. That CPA is going to take the place of that 102 CAP plan, and then the DIA is something new. So the DIA is for the TSP to verify and add that soil testing component to help that landowner lock in a decision before they move to contracting conservation practices. NRCS, we can do that as well. We can have conversations with the landowner. We typically would do our soil test pits later in the design phase, but that could be completed now earlier by a TSP.
And Tim, relating to that, does NRCS have any oversight on those CPAs and DIAs and SEMAs as they come in? Are we supposed to be doing any kind of reviews or anything like that for those?
Yeah, same process that we've always done. You know, that they, when I was in the West as area engineer, TSPs would typically reach out to engineering staff, and we really liked to tag along on site visits when they were going out. And that process worked really well. And then when they were completing their I&Es, they would send it in. I'd do a quick review of it, might have some comments to send back, and go from there. So that same process should continue. And the same thing really should happen for the DIA. I don't really expect the DIA is going to be a very extensive report on the engineering side of things. I think the DIA is going to be much more involved for our agronomic or ecological sciences practices. They're going to have to, TSPs are going to have to complete implementation requirements as part of that stage, and there's a lot more involved for the non-engineering practices. For the engineering, it's really just verifying, making sure that the CPA 102 is good, and adding that soil test pit. So, or multiple soil test pits if appropriate, but at least one soil test pit. Did that answer the question, Heather?
I think so. I appreciate that. There are no other questions that have come in, so I think you're done for the day.
That works. Thanks, Heather.
Yeah. So I get the privilege of wrapping the day up. You've heard a lot about bioenergy today, from biochar to poultry litter burners to nutrient offerings. It was a bioenergy heavy theme, and we appreciate all the presenters. We especially thank Dimitri for stopping in and giving us a walkthrough of Design Guide 12. When you dig into it, there's a lot of information in there. So pay attention, and as always, please reach out with questions. Thanks to Mark for showcasing the big construction project going on at Beaver Creek, and to Tim for the programs update. As always, if you have any questions, please reach out to any one of us, and we'd be happy to pass them on to the presenters if we can't answer them directly. We also would appreciate if anyone has ideas for future engineering workshops and roundtables. We're always looking to get ideas, and because you're the ones who drive it. What do you want to know? What are you interested in? So with that, I have one last joke for you, just because I think this one's my favorite. So I'm hoping you enjoy it too, and then you're sprung for the rest of the day. What do you call a frog hanging from the ceiling? Realizing the time of year we're in. That's your clue. And the answer is a mistletoe. So with that, I hope you have a wonderful holiday season, no matter which holiday you celebrate, or all of them. And we will be back with you in the new year with some other fun engineering workshop. Have a good one. Thanks again. Bye.